Hey guys, so I am back after a very long hiatus, but this is going to be the beginning of a Algebra 2 series, and this first lesson is going to be over functions. So let's go. So what is a function? Well, in short, a function is really any equation where you put in one x or independent value and you get out exactly one y or dependent value. So if you look at the chart on the left on examples of functions, you can see that the 1 corresponds to the 8 and only 8, the 2 to 9, 3 to 11, and 4 to 9 respectively, but each x value only goes to one y value. And examples of graphs that fit is y equals 4x plus 6 with that linear line in blue on the left. And as you can see, it is a function and also what you call a one-to-one function because there is one x value for one y value for that like one x value only. But it's kind of weird to explain it, but it makes sense if you look at the next equation where it is y equals x squared plus 3, my bad, and that is a function since there's one x value for every y, but it's not one-to-one because there's two y values for different x values, and it's not really one-to-one. But examples of non-functions would be something like on the right chart, the 2 goes to the 9 and 11, and that means it cannot be a function since one x value can have two possible y values. So an example would be x equals 6, where at the point 6, there is really infinite values for what x can be. I mean, for x equals 6, there's infinite y values. And then for x squared equals x, for, let's say, the point 3, x equals 3, there are two possible y values for the function. I mean, the equation, so it cannot be a function. And a really easy way to test it is what they call the vertical line test. Vertical line test, where you put a straight line through the graph of the equation, and if it only meets at one point, then it's a function. But for anywhere on the graph, it can meet at two or more points, then it's not a function. And let me scroll down. Okay, let's move on. So, which of these functions represent y as a function of x? Let me expand this out. So, is the equation x squared plus y equals 1 a function? Well, to solve this problem, you have to solve for y. So, let's subtract x squared from both sides. So, you get y equals 1 minus x squared, right? And now that you have y, let's just give an arbitrary value to x. Let's say x equals 3, right? So plug this back in. Y equals 1 minus 3 squared. Y equals 1 minus 9, 8. And since there's one x value, which is 3, and it only corresponds to one y value, which is negative 8, then it's a function. And let's do a different problem. Is the equation negative x plus y squared equals 1 a function? Well, now we have to solve for a y again. So you add x, so you have y squared equals 1 plus x. Now, to solve for y, take the square root of both sides. So you have, So you have y equals the square root of 1 plus x. And since you take the square root of a variable, it can be positive or negative square root. So in this case, if x again equals 3, you have y equals the plus or minus the square root of 1 plus 3, or y equals plus or minus 2. And since for one x value, there's two possible y values, it cannot be a function, so no. Let's move on. So sometimes you may be asked to evaluate functions. So let's say an example function g of x, right? And also the notation for functions is like f of x, g of x, h of x, really any letter you like, but That's the notation. So let's say g of x equals negative x squared plus 4x plus 1. And let's try to find g of 2. That means you have negative 2 squared plus 4 times 2 plus 1. That's really bad, 4. Now, so you have 2 squared is 4, and there's negative out here, so negative 4 plus 4 times 2 is 8, so that's 8 plus 1, and you have 5. Now, let's do a different problem. Let's say you want to find g, oh, my bad, g of t. Well, all you have to do is substitute t everywhere you see an x. So now you have negative t squared plus 4t plus 1. Easy like that. I mean, easy as that. And now let's do the final problem on this slide, which is, it's a little harder, but still doable. So g of x plus 2. So for everywhere you see an x, you put now x plus 2. So now you do negative x plus 2 squared plus 4x, I mean, no, not 4x, 4 times x plus 2 plus 1. So that means you get negative, just expand this out, so x plus 2 plus 4x, because distributing, plus 8 plus 1. If you FOIL out the negative, the x plus 2, you get negative x squared, negative on the outside, plus 4x plus 4, plus 4x plus 8 plus 1. And now you have to distribute this negative in. So you have negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. And now this simplify. So there's a negative 4x here and a positive 4x there. So these cancel out. So now you have negative x squared. Negative 4 plus 8 plus 1 is 5. So plus 5, and that is your answer. And sorry for my terrible writing. This recording process is not perfected yet, but I will figure out better ways to record videos and probably have better writing. Okay, let's move on. Okay, so you may not need to know this yet, like in depth, but I feel like it's a good thing for you guys to get a basic understanding of what this is. And this is what you call a piecewise defined function, where it is a function, but for different x values, you have different equations. So what I mean is, look at this picture over here, where f of x equals x squared plus 1 if x is less than 0. So on the graph on the left, you can see that there is an x squared plus 1 graph for x is less than 0. And then you have x minus 1 for if x is larger than 0. So that's why you see a linear line on the right. And you may be asked to find f of negative 1. Then that means since negative 1 is less than 0, you would use the x squared plus 1 equation to solve. Or if you have x equals 1 or f of 1, you would use the x minus 1 equation since x is larger than 0 in this case. Let me expand this back. And now just a couple problems with functions. So find all values when f of x equals 0 and f of x equals x squared minus 8x plus 15 equals 0 in this case. So what you want to do here is this factor, right? So you want to find values that multiply the 15 and add up to negative 8. Well, you can do x minus 3, x minus 5 equals 0. And now you make each of these equal 0, like this. So x equals 3 comma 5. Easy enough, just algebra 1, so factoring. And let's do a slightly harder problem, but still totally possible. So find all values of x where f of x equals g of x. And they give you f of x and g of x. So this is just saying find x where the square root of x minus 4 equals 2 minus x. So the first thing I would do in this situation is isolate this square root. So just add the 4. Square root of x equals 6 minus x, right? Now I want to square this square root of x to get rid of it. So I would have x equals 6 minus x squared. Now I can expand out this, and I would get 36 minus 12x plus x squared, right? And then all I have to do is subtract this x. Oh, okay, not working out. Subtract x, there you go. Right, this get rid of it, so now you have 0 equals 36 minus 13x plus x squared. And then you can rewrite this to make it look more like the standard form of a quadratic, which is x squared minus 13x plus 36 equals 0. Now just factor. So you have x minus 4, x minus 9, since these add up to negative 13 and multiply to 36. So x equals 4, 9. But you're not done yet. Now you have to plug these values in to the f of x and g of x to make sure that they equal each other. So let's do f of 4, which is the square root of 4 minus 4, negative 2. G of 4, where it's 2 minus 4, negative 2. So you can say that 4 is an answer. But now let's try f of 9, my bad. So the square root of 9 minus 4, 3 minus 4, negative 1. And now g of 9. So you have 2 minus 9, which is negative 7. Negative 1 does not equal 7. So 9 cannot be an answer. So the real answer to this problem is x equals 4. And that's it for this video. See you guys in the next lesson.